A warm welcome to all the viewers. In this session, I will be discussing about variance and standard deviation. I will explain to you both the concepts, where are they used, how they are used, and what is the relevance of both of them. Along with this, we will see a manually solved example on how to calculate the variance and standard deviation of a given data set. And we will also find out why there is n minus 1 instead of n, that means sample size, in the denominator for calculating the sample's variance and standard deviation. So I will be showing you the formula for variance and standard deviation in case of a population and in case of a sample. So stay tuned, keep watching. Now, these are the four formulas. Don't be worried about these formulas by looking at them, though they look a little difficult. But let me assure you, once you see this video, you will become quite familiar with them and you will be able to use them quite easily. So, this is population variance. This is population standard deviation. This one is sample variance and sample standard deviation. If you look closely, you will find that there's not much difference amongst these formulas in case of a population variance and sample variance. The difference is only in terms of minus mu, which stands for population mean, and in this case we have minus x bar, which is the sample mean. In this case, we have the population number. What is the population size? That is why it is capital N. In this case, we have the sample size, which is small n. But why it is n minus 1? The question is why it is n minus 1? Why not just n? So I will be telling you why it is n minus 1. Then we look in for population standard deviation formula and compare it with sample standard deviation formula. Here also you see mu, which stands for population mean, and x bar stands for sample mean. Here again we have capital N, which is the population, and here we have small n, depicts the sample size, again minus 1. So before going into the details of why there is n minus 1, let us understand what is variance and what is standard deviation. Variance is basically the average of the squared deviations from the mean and is expressed in squared units, whereas the dispersion of data set relative to its mean is calculated as the square root of the variance and known as standard deviation. It is expressed in the same units on which the original data was measured. So both are the measures of dispersion of the data, and the difference is clear to us now. Now let me give you one example over here. If you see closely in this case, if we look at the population, the entire set of people or respondents in the population, and we know the population mean is 4. So taking 3 observations from the population, so if we have 3, 4 as the observation, and the deviation in this case is minus 1. How come? 3 minus 4 is minus 1. 4 minus 4 is 0. Why I am doing 3 minus 4? You see here, population variance. This thing is known as deviation. So the score or the value minus the population mean. So 3 is the score and 4 is the population mean. So I just simply minus it, subtract it, I get -1. Here I get 0. So what could be the third value? It could be any value. It could be any value out of the population. But if we see the case of a sample where we know that the mean is 6 and there are 3 values in the sample, 3 respondents are there. So in this case, the first value is 4, the second is 7, the deviation 4 minus 6 is -2, 7 minus 6 is 1. So what will be the third observation? Now in this case, all sample deviations, this one, must sum to 0 because the sample mean lies in the middle of these deviations as per the definition of sample mean. So there are only 2 independent places of information in the sample data set, which are known as degrees of freedom. So to make it 0, the third value should be 1. So 1 plus 1, 2, 2 minus 2 is 0. That makes the deviation sum equal to 0, right? It will be 7 once more. Now, there's one more reason for that. That is why we make it n minus 1, which depicts the degrees of freedom. So, when we calculate the sample mean from a sample size, we use 1 degree of freedom. And there are only n minus 1 independent values remaining, as in this case I told you. So, out of the 3 values, only 2 values are independent. The third is fixed because we want a deviation sum to be 0. But that is not true in case of population. It can take up any values. Sample mean is usually closer to the sample data points than the true population mean. Therefore, there is n minus 1 in the denominator, which is an unbiased estimator known as Bessel's correction for the population variance. Now this could be another reason for this n minus 1. To adjust in for the sample mean, which is usually closer to the sample data points and rather away from the true population mean. So it is away from the true population mean. So to adjust for this bias, we put n minus 1 in the denominator, known as Bessel's correction. Now let us see one example on how to solve this thing manually. So a data set consists of these 6 numbers, 4, 8, 6, 5, 3, 7. So this is the sample data set having 6 values. Easily I can put these values in the formula. How to do it? First I calculate the mean. So I add up 4, 8, 6, 5, 3, 7 and divide it by 6. So it comes out to be 33. 33 divided by 6, 6 is the number of observations. It comes out to be 5.5. That is the mean of the sample. Sample mean. Second is calculating the variance. So here I make the square of deviation. Deviation is the score or the data point minus the mean. Data point minus the mean. This is known as deviation. And squared difference of deviation is this 2.25 for the observation which was 4. For the observation which was 8, it is 6.25. So this is the way I'll take out the squared difference for each observation, each of the 6 observations, and then I sum them up. It comes out to be 17.5. Then I divide the number of data points by 6. Why 6? Because in case we are doing a population variance, then in that case we divide it by 6. But if we are doing a sample variance, in that case we will divide it by 5. So here the thing is to be noted that we are calculating sample variance, not the population variance. So if we just divide it by 6, that is a wrong formula for calculating the sample variance. As I told you, the Bessel's correction, so this has to be 5, 6 minus 1, because there are 6 observations, n minus 1, 6 minus 1 is 5. So we will get the variance and then we'll take out the square root of that variance to arrive at the standard deviation. So this is the way we calculate sample variance, and had it been population, had it been the entire population say, then we would have used this formula without n minus 1 taking 6 over here. If we are doing it for sample, we must take n minus 1, that is 5. So that will come out to be around 3.5. So that is how you do the manual calculation of variance and standard deviation. I hope the video was quite informative and useful for you, and you will definitely share it with your friends and faculty colleagues. Stay tuned and keep watching, keep supporting the channel for more informative content. Thanks a lot.